Can you see them?
Yes, now we can. Awesome. Thank you.
All right, very good, very good. Okay, cool. Well, so on that note, these slides and the recording will be sent to you within the next 24 hours. So if you have to drop or you can't stay for whatever reason, don't worry, you'll be able to get them, and you can share them with your colleagues and review them at your leisure. So we have a lot to go through. Let's go ahead and get started. As a way of introduction, my name is Matthew Shear, marketing manager here at Rancher. I host some of these trainings as well as our Thursday Intro to Kubernetes and Rancher sessions. On our line, and the creator of this topic is Adrian Goins, Senior Solutions Architect, and helping me get the slides going for you guys too. Thanks, Adrian. That's right. And we're really pleased to have OpenEBS leadership team here with us, Uma and Murat. So glad that these guys could join us and share their knowledge and go through a demo. It's going to be really cool. So thank you guys for joining as well.
Glad to be here. Thank you.
Yeah. Hey, guys. All right, a couple housekeeping items before we dive in. This is a class, and we try to keep it to around an hour, 40, 45 minutes for the presentation and demo, and then a ton of time for Q&A afterwards. So please put your questions into the GoToWebinar chat. It's got a really cool feature where you can ask us anything you want, and we try to do our best to answer every single question. Because there's a lot of presenters today, please, if you're able, direct your question at Adrian or Uma or Murat. So Adrian or OpenEBS. That way we know who should answer. It'll just make things a little bit easier. And if you do want the question to be private for whatever reason, just mark it as such. Otherwise we'll answer the question for everybody. And again, this is educational. Ask a question on on whatever you need to learn to get the most out of the training. If we're able to answer it, we will. If we know another resource, we'll direct you there. This, as I said at the beginning, the session is being recorded. It'll be posted on YouTube. The slides and the session will be emailed to you. We have a ton of trainings on various topics around Kubernetes, storage, all sorts of things. So if you go to youtube.com/c/rancher, then you will be able to see all of our past recordings and learn as much as you want. If you want to join the conversation, hear about other announcements, see the materials posted there too, join our Slack, totally free. I think a lot of people on here are already members, and we have hundreds of people asking questions, participating on Slack every day, thousands of members. So go to slack.rancher.io and you can create an account and you can join the Pound Masterclass channel in order to hear announcements about these training sessions or online training channel, that one for more general discussion about training too. And we have a lot of other classes coming up. So next week we'll be going through load balancing with Kubernetes that Murali is going to present, and we have Wizards of the Coast developer team the following week talking about multi-cluster management and production environment. So there's a lot of cool stuff coming up. So please join and participate. We'd love to see you at multiple sessions so you can continue your learning journey. So now that all of that is out of the way, I'm going to pass the presentation over to Adrian, and he can dive into the heart of the material for today. So I'm making you the presenter, Adrian. And I can see your slide. I can, yes sir, go for it.
Fantastic. Hey everybody, my name is Adrian Goins. I've been building internet infrastructure since 1996. I've been building cloud infrastructure since 2008, containers since 2004, and I've been neck deep in Kubernetes since 2016. Today we're talking about standalone servers and scalable secure storage. But really what I want to talk to you about is how you can build reliable Kubernetes clusters without spending a lot of money, and how you can defend yourself against the things that are designed to steer your emotions towards spending lots of money. Never in the history of technology have we been bombarded with information at the rate that we are today. It's overwhelming. If you look for answers, you'll find them from everywhere, some better than others. And as creatures who are designed to filter data and extract value, we take shortcuts to arrive at our destination. Now, I don't have enough time in the 20 minutes that I have today to tear apart the forces that manipulate you and get you to take action, but I have enough time to show you a piece of it, one small piece. You don't need to do what everyone else is doing. And even simpler, you shouldn't believe what other people tell you. You want to, because it's easy. You can use this to build on the experience of others, and in a lot of circumstances, this will turn out well for you. In other circumstances, the ones that we'll discuss today, it'll connect you to a drip line of value that's designed to extract from you the one resource that matters, and that's your money. Your money is what lets you do things. It's what lets you hire employees, buy what your business needs to expand, and ultimately, if you're doing it right, grow and survive periods of economic downturn. Now, money isn't what creates happiness. We all know that. But money absolutely is your biggest asset. The more of it you keep, the better you are. The more of it you give away, the worse you are. I'll do this in the context of how to approach building a Kubernetes cluster, but it applies to everything in your life. So let's just start with this. The things that you want to do cost less than you think, and they can be done with fewer resources than what you've been led to believe. The more that you express this in your work and in your life, the more freedom that you'll have. Meet Mark. Mark loves technology. Mark really loves Kubernetes. When he thinks about solutions, he looks at what other companies are doing. He figures those companies have smart people, they make lots of money, and so they must have done the research before they chose that solution. And if it works for them, well, then it'll work for him, right? This is a shortcut. Kubernetes is so flexible with so many ways to do things and so many things that you can do with it that it's super easy to overengineer. Now, Mark doesn't see anything wrong with overengineering because it makes him feel safe. It masks skill gaps, and he can find an abundance of ways to build things that protect him against failure. I mean, failure, after all, is the worst thing ever. In reality, overengineering increases your demand for resources. Now, Mark doesn't have a warehouse full of pre-built servers that he can fire up in an instant, so he goes looking for help. And he finds it in the cloud. In the cloud, he can get access to all that he can eat whenever he wants. He just has to pay for what he uses. Now, don't get me wrong. I'm not here to say that there's no value in the cloud. I'm not against the cloud in any way. There's tremendous value in the cloud. There's also tremendous value in painkillers. Cloud providers don't sell resources. Like, it seems like they do, but that's not their primary business. Their primary business is about selling convenience. If we take away the convenience, there's a point where it costs more to use the cloud than it does to run a data center. Beyond this point, we still find companies using the cloud. Why is that? Mark started out with small instances. They seemed like they had enough RAM and CPU, but performance was low. His provider told him that he could get better performance from larger instances. Then he saw some issues with network performance, and he realized that for some reason his instances had 100 megabit virtual interfaces. His provider told him that he could get gigabit interfaces on larger instances. And then he saw I/O issues with disks. During peak times, his instances would come to a screeching halt with I/O because he'd maxed out some limit. His provider told him that he could get better IOPS if he moved to bigger disks with dedicated IOPS. All businesses make more money upselling existing customers than they do acquiring new ones. In an industry where customers choose the things that they buy, one way to upsell them is to offer a lower quality of service at entry-level tiers. Another is to offer them everything that they need in one place. Cloud services are not designed to save Mark money. Like a Vegas casino, forgot about that, dude. Like a Vegas casino, they know that only a handful of people who come through their doors have the chops or the inclination to accurately model their consumption and budget for it. That guy is Mark's CFO when he gets the bill from his provider. He looks like this every month. How many of you know that guy? Now, let's talk for a moment about human psychology. The consistency principle states that people will act in a way that allows them to remain consistent with their self-image. That sounds totally obvious. Imagine that a person who believes himself to be nice gets into an argument and hits the other person. Well, hitting people isn't nice behavior, so he might blame the other person for driving him to that extreme. Look what he made me do. This allows him to remain consistent with his self-image. That's a really basic example, but it gets weirder. Gamblers at a racetrack were asked to rank how likely they thought it was that a horse would win a race, both before and after they placed a bet. All of them reported higher confidence after they placed the bet. In another study, researchers asked homeowners to put an ugly billboard on their lawn that supported safe driving, because we all want safe driving, we don't want to run people over in our neighborhood. They found that homeowners were 400% more likely to approve of the billboard if they had first consented to put a small postcard in their window only 10 days earlier. If you carry this over to why people buy things, it says that someone who has purchased from you once is more likely to purchase from you again, even if the first purchase was insignificant. It also means that Mark will defend the provider, will rationalize his behavior, and he will place blame outside of himself in order to remain consistent in his mind that he made the right choice, even when new information reveals that that choice was obviously wrong. Mark wants to use the provider's database service. It comes with a multi-area fault-tolerant backup and automatic replication and load balancing and failover, and it's basically plug and play. Except it's not. He still has to pay for instances and data transfer. He still needs a DBA. The more services that he uses from his provider, the more he needs a new team of cloud architects to make sure that everything is built correctly and talking through all of the APIs. This new team exists because the cloud provider exists. Now, do you think that they exist to help Mark save money or to help him consume more services? Something like a failover solution gets designed and built once, whether it's on-prem or in the cloud. Mark doesn't know how to do it, so he places tremendous value on the solution. And because humans correlate price with value, he's willing to pay a premium. The economy of scale to the provider is tremendous because they design it once, they automate it, and they stamp it out for every client. It basically costs them nothing. But the difference is enormous. Now, the thing that I find most interesting about all of this is the continued use of services when the costs far exceed the benefit. The cloud is about pay for what you use, as if we're not going to run services 100% of the time. I mean, I'm not talking about Netflix scaling up and down under demand. The majority of businesses that are using the cloud are businesses who wouldn't otherwise be able to build a data center. They don't need vertical auto scaling. Most businesses using cloud resources also don't use spot instances, and they don't prepay for reserved instances. And I know that those are Amazon terms, but apply that to whatever cloud provider that you want. The point is that they continue to pay because they don't know any better. I mean, it's almost as though the decision-making process has been short-circuited by something else. Inexplicable behavior is often a side effect of the brain seeking short-term satisfaction. That's addiction. You can see it in drug addicts, you can see it in people using slot machines, and you can see it in people clicking the like button on Facebook. Now, are we addicted to the convenience of the cloud? I don't think anyone craves cloud services, but how much easier is it to spin up resources simply because they're available? Is it the same as an alcoholic relapsing because there's vodka under the sink? How many businesses run environments that have become so large and so complex that they can't be reduced? How many businesses continue to use services far beyond the value those services provide for what they cost? Nothing that I'm saying today is meant to say that the cloud providers are doing anything wrong. They're doing everything right for them. It only takes a small shift in perspective to take the teeth out of the bear. Meet Catherine. Catherine also loves technology and Kubernetes, but she's aware of the danger and she wants to keep her costs within budget and still have a margin of safety. So she starts by looking at projects that are similar to hers in size, and she models her project off of those designs. She chooses technology partners who are focused on solving one part of the equation. Companies who do one thing well continue to grow and add value over time. They behave as partners, not vendors. Now, failure is inevitable. This dog spent his entire life catching tennis balls. Do you think his owner's gonna put him to sleep because he missed this one? This guy fumbled the football 2 minutes before the end of the Super Bowl. His team was in the lead. The opposing team recovered the fumble, scored a touchdown, and won. Did he get fired? No. His team recovered, fought their way to the Super Bowl the following year, and won. This wall was 700 feet high and was designed to keep out the army of the dead. Men defended it for 1,000 years. One mistake north of the wall led to the enemy resurrecting a dragon and using it to destroy the wall in minutes. Was the man who led that mission executed? No. As humans, we dread failure. We think it's going to be the end of the world, but it won't be, at least not unless the army of the dead is involved. In 2017, while fighting back against spammers, an employee at GitLab accidentally deleted 300 gigabytes of data from the production database, effectively nuking 6 hours of customer content. Was he fired? No. GitLab announced the failure and they live streamed their recovery efforts. The response from the community was staggering. Thousands of people sent their love and support to GitLab, praising them for their transparency and admitting that at some point, we have all been that person. GitLab is a stronger company today because of the experience, how they handled it, and the changes that they put in place afterward to prevent it from happening again. When I lived in New York, I met a Buddhist monk, and she told me, we make rules because we learn lessons. This is how we grow. In 2017, in his article titled, "You Are Not Google," Oz Nova introduced the world to unfat. This is a simple system for thinking critically about technology solutions for a problem. Understand the problem first. I mean, really understand it. He recommends that you solve the problem within the problem domain, not within the solution domain. Enumerate multiple solutions. Don't pick the solution that's the sexiest or is going to be the most fun. Don't change the definition of the problem in order to make the solution fit. Consider a candidate solution, and then if a white paper exists, read it. Do research and learn about the benefits and the drawbacks of the solution. Find out what its real costs and its hidden costs are. Determine the historical context for the solution. You can read Oz's article to learn why Kafka and Cassandra and service-oriented architecture were created or adopted by large companies. Does the problem that you're facing have the same requirements? Weigh the advantages and the disadvantages. Everything is a trade-off. So what did the creators of that solution have to give up in order to gain something? And finally, think. This doesn't mean mull it over a little bit over lunch or on your way to the train. It means get away from distractions and truly think about it. Roll it around in your head, listen to your heart, and listen to your gut. Make sure that you're making a decision from supporting evidence, not diving headlong into the next greatest thing. New does not mean better. RKE is a Kubernetes distribution from Rancher Labs. It uses a declarative syntax to define the cluster, after which you can run RKE up to apply the changes. It's like magic. What it gives Catherine is the ability to easily scale. So when she's just starting out or building a cluster for development, she can run a single node cluster. When she's ready to expand to HA, RKE up. When she's ready to separate workers from masters, RKE up. When she wants more workers, RKE up. When she's ready to separate control plane from data plane, RKE up. And when she's ready to add even more workers, RKE up. Catherine could deploy Kubernetes across availability zones, but to maintain quorum, she would need to favor one of those zones. This nullifies fault tolerance. If the zone with the 2 etcd nodes goes down, the one remaining node is not going to elect itself as a leader. Workloads will continue to run, but Kubernetes is already designed for workloads to continue running, even if all of the Kubernetes management plane is down. Instead of building one Kubernetes cluster that spans 2 or more availability zones, she uses Kubernetes as an availability zone. A solution like Rancher's multi-cluster apps and global DNS unite multiple clusters under a single management plane, deploys apps to all of the clusters, and routes traffic between them. Now, if an AZ were to go down, all of the resources for the cluster and the remaining AZ, including its management, are still available. She's increased her actual fault tolerance, and she's reduced the bill for inter-AZ data transfer. Catherine considered attaching volumes from the provider directly to her Kubernetes workloads, but she didn't like things like minimum volume size requirements or the low throughput for small NFS volumes. So instead, she went with container-attached storage. This lets her deploy replicated storage within Kubernetes with features like clones, snapshots, and fast failover. She can use larger volumes from the cloud providers, resize volumes, and can deploy solutions like NFS or object storage within Kubernetes. The thing that she likes most of all is that her storage is now abstracted from the cloud provider. She can migrate from dev to production or from one provider to another without changing the configuration within the cluster. Now I'm going to pause here because OpenEBS is on this call and they can do a far better job of demonstrating the value of container-attached storage than I could. So I'm going to pause and let them take it over and show you this amazing piece of technology. If you guys want to take over the presentation.
Hello, everyone. My name is Murat Karslioglu. Trying to share my screen in the meantime. Can you see the slides?
We see your desktop, not the slides.
Oops.
Oh, and now I'm the presenter again. Let's see, let me
Move it up here. Yeah,
it's okay.
it always happens last minute.
Change presenter. Oh, wait, looks like you got it again.
Here we go.
Yep,
Slides.
there we go.
Yeah, okay. Hello, everyone. It's a pleasure to be here. And my name is Murat Karslioglu. I'm the VP of Product for Maya Data, company behind OpenEBS and Litmus and few other open source projects for Kubernetes. Today's agenda, so we'll go quickly through OpenEBS, what it is, then what is container attached storage, and we'll spend more time on the demo part. So that's where we want to focus. But quickly for the audience who are not familiar with Maya Data or OpenEBS, Maya Data and the company has been around a little bit over 5 years, and previously, before containers were a buzzword, so we were using containers in free BSD jails to containerize storage and provide QS for storage. And an OpenEBS project has been around since late 2016. We started around the end of 2016, 2.5 year almost, and a lot of traction and a lot of GitHub stars, over 400 contributors now, and a large Slack community, and hundreds of Rancher users. And that's why another reason why we are here today. So Maya Data, our mission is data agility. So it is not just the storage piece. OpenEBS is one part of it, to be able to provide data agility with all the tooling around. And a little bit about OpenEBS. Everybody is, I'm pretty sure, familiar with this architecture, what Kubernetes is. This is just for comparison how OpenEBS plays a role here. In Kubernetes, you have your master or multiple masters and multiple worker nodes and pods inside. OpenEBS itself is a completely containerized, and this is what this is basically the definition of container attached storage. We containerize the storage firmware itself, and everything is orchestrated through Kubernetes again. Once you install OpenEBS, and I'll quickly walk you through that, it is literally 30 seconds one-time process you install on your cluster. It's even easier with Rancher now. So we are a official Rancher partner. You can go to Rancher catalog and install OpenEBS just by simply clicking on catalog item. Let me actually share the screen here. And so after you install OpenEBS, and like I said, Maya Data is a data agility platform. On top of it, we have a visualization and then login and a bunch of other things that Uma will walk you through after the installation demo. That is an add-on, which is our commercial offering. And a little bit more about the CAS, what it is, like I said. One of the reasons why we are moving into microservices is, of course, this DevOps agility, and it's much faster and easier to deploy containers. In the meantime, why are we moving our applications into microservices but keeping storage as a monolithic legacy storage, which cannot really handle 1,000 different workloads? One of the main reasons why we started OpenEBS project is exactly to address that issue, because in a containerized environment, especially after moving number of VMs on hypervisors to hundreds of thousands of pods in containers, so you quickly realize that there is a IO blender effect. So if you put different type of workloads, databases, or your logging, or NFS server, S3, all containerized application into one black box, then you have this optimization issues. Which workload do you want to can you optimize your storage for? But so again, the idea of OpenEBS, exactly the same reason why we move our applications into microservices. Now we can also move storage closer to the application and orchestrate the same way we orchestrate our application. And this gives us a lot of native advantages of Kubernetes. By doing that, you abstract the storage layer, and it doesn't matter what is under. So you may be running on a cloud, AWS, Google, Azure, or on on-prem, your also Rancher cluster. Doesn't matter what storage backend you have. Today might be a cloud, or on-prem or multiple on-prem clusters. You can migrate your workloads easily by abstracting the storage layer. And this also gives your architect a easier way to, again, provide a unified storage experience to their developer. So, and it can be even transparent. Let's say from a CIO or VP's perspective, you are running your cluster today on AWS and you understand the related cost, and tomorrow you want to move some of the workload to on-prem. So if you rely on cloud APIs, you are pretty much locked because data has gravity. So the only way to do that and keep your workloads on developers vendor lock-in free is also abstract the storage layer, containerize the storage layer, and OpenEBS is exactly doing that with Rancher, and now we are seeing hundreds of also users running on OpenEBS on Rancher. Quickly, a couple of seconds on the architecture, maybe a bit more details than we want to know, but what's in the control plane. So OpenEBS, like I said, is completely orchestrated by Kubernetes itself. We have a provisioner and a scheduler that talks direct to Kubernetes APIs, and then you can think it as an application-defined storage. When you deploy an application, your storage is on demand deployed at the same time. This way you have this agility, and you don't need to go to your storage admin or any other gatekeeper and ask, I need to have additional 100 megabyte and wait for that. So you can quickly provision your application. And another benefit of all this architecture and solution is, so you don't need to over provision. And then one of the biggest problem, Adrian also mentioned, that is over engineering and over provisioning. When you consume cloud resources, it feels like one click away. Most of the time you over engineer or over think or over provision, and you see the result when you get the bill. And so by containerizing your storage, you can thin provision and you can increase the storage when you need, actually when your application consumes it. So I'll quickly get into the demo part, like I mentioned. And one thing before you start, we have also guides, a quick start and prerequisites guides for Rancher. You can go to docs openebs.io and go through based on what operating system you use, Rancher OS, Ubuntu, or CentOS. You can find the prerequisite parts. The only requirement to get started with OpenEBS is the iSCSI initiator, and most of the time this is something already installed in your environment. If not, you can validate and get started with OpenEBS quickly. So again, OpenEBS is completely open source project. You can find the instruction. This time I will pick the hard way to install and then go through the CLI on my Kubernetes cluster to show you the steps. Literally using the Rancher UI, it is a click easy, but this time I will walk you through the long way, which is also a 30-second installation. So let's take a look at my kubectl get nodes. Take a look at my environment. So I have 3 worker, 1 master, and so nothing installed in OpenEBS, namespace either. So you can use Helm charts, you can use YAML, apply your YAML file and install. You can use the Rancher catalog. So this time, because I want to also use the demo applications from the repository, I'll show you the operator way of installing it. And let's watch what is happening here. Kubectl get pods open. By default, everything is installed in OpenEBS repository, like I said. And quickly going through the components we have here, you can see from bottom up, snapshot operator. OpenEBS has a snapshot and clone capabilities, and it is using copy on write, so it is literally zero copy snapshots, very efficient. And then you see the NDM part. I would encourage you to take a look at this separately. So this is called a Node Disk Manager, an open source project OpenEBS team has developed and proposed to Kubernetes. At some time it will be probably upstream into Kubernetes. It creates the disk resources as custom CRDs in Kubernetes, records on etcd. So once you install OpenEBS, you have better visibility into your disks, and you can query disks like kubectl, get disks, storage pools, and get disk information from smart and then understand if any latency issue or performance issue is also related to disk health. So less than 30 seconds, OpenEBS is installed. Now I wanna move back to the repository, and so since I have some demo files here, also let's git clone OpenEBS into my nodes. And you can find a couple of demos, quick get started with OpenEBS. So I'm gonna try to apply a Percona, deploy a Percona database on my setup. A quick look into what is required to add OpenEBS as a persistent volume into your application. There is only one thing. When you deploy OpenEBS, it comes with default storage classes. You can find instructions to create your own storage classes. But when you create an application and then that creates a persistent volume claim, you only need to mention that storage class, and rest is automated by OpenEBS. So what I need to do right now, just we can get the list of get a list of pods available. Nothing here. Apply -f Percona OpenEBS and deployment YAML. So this is gonna create, like I said, everything is orchestrated with Kubernetes. This is going to create a couple of things. First of all, I used one of the built-in storage classes, which you can easily customize. Instructions are on the docs, openebs.io. But this storage class required 3 replicas, and OpenEBS orchestrates and make sure those replicas are placed on different nodes, and that so your application can survive any node or infrastructure failure. But as you can see, what is happening here, OpenEBS provisioner called Kubernetes API, and it create 3 replicas and a controller for PVC, and this is pretty much to provide storage, persistent storage for that Percona we deployed. So 3 replicas are placed into 3 different nodes, and the controller serves as an iSCSI target. And this is also headless, and you can call it stateless. That means controller and your application, wherever it is hosted, a node can die, and Kubernetes will schedule them on another nodes. And once they are up, they will detect the surviving replicas, and connect to your data. So let's see. So yeah, very quickly, so my application is now up and I can check there is a PV created, 5G it is bound, that comes from the PVC and that comes from the storage class. One more thing before I hand my demo over to Uma, so you can describe. Let's see, take a look at OpenEBS GWAL default storage class. Oops, sorry, I forgot. So as you can see inside the storage class, so there is a default capacity. You can change it with your application or PV claim. And then you can see the replica count that requires 3. So if your application also replicates like databases, you can choose to have 1 replica, but this is pretty simple step. I will hand it over to Uma now.
All right. Can you guys see my screen? Yes. Hi guys, my name is Uma Mukhara. I'm a co-founder and COO at MyData. Very glad to be here. And thanks Adrian and Murad for those wonderful demo and a lot of insight into how to build Kubernetes in a more economical way using RKE. It was a good session. So here, I think I have about 5 minutes. So what I want to really show quickly is, how can you use Maya Online and another open source project or a part of our software commercial bundle called Litmus. I'll just spend a couple of minutes on how Maya Online and Litmus together with OpenEBS can really be complementary to Rancher as a solution in building real persistent storage in your Kubernetes clusters. So as you can see here, Rancher is the Kubernetes management platform, and Maya Online is a cross-cloud data management platform that gives visibility at the moment, and in near future, it will give the data migration capability from any cluster to any cluster of the data that gets managed by OpenEBS. And OpenEBS is a solution that can provide persistent storage in a container attached storage architecture model to all the stateful application that runs on your Kubernetes clusters. Think of it as like an EBS on AWS. Similar to that, you're running a more containerized storage on your on-prem. So what Maya Data provides is, of course, it's behind the sponsor behind OpenEBS and Litmus project. We're also working on Node Disk Manager, as Murad demonstrated. NDM is completely open source, and we're hoping that it will be upstreamed to Kubernetes at any time. But what Maya Data really provides is the data agility platform is a cloud data layer that really gives you a visibility of your data across the Kubernetes clusters, and also it helps you provide assurance of your data, right? That's the Litmus part, and then it also provides DMAS, data migration as a services. These are the features that Maya Online and Litmus and OpenEBS together can provide, and it can run anywhere, just like Kubernetes that can run anywhere, gets managed with Rancher. Using Maya Online, Litmus, and OpenEBS, you can build a data layer that's really simple to manage and very feature-rich and scalable. And how we do that is using MDAP. It's a Maya Data Agility Platform. It really contains 3 pieces. OpenEBS is what Murad has demonstrated. It's the real storage layer that provides data provisioning as well as management layer. Litmus is the infrastructure, chaos engineering infrastructure that lets you validate and harden your applications and infrastructure, Kubernetes infrastructure or RKE, before you really go into the production and after you're in production as well. And Maya Online is the visibility platform and data migration platform that helps you manage, more of a day-to operations for all types of persona, right from developer to the DevOps, admins, and the VP software. And then, of course, it comes with the proactive support. I think I got about a few more minutes before we get into QA. I just wanted to introduce Litmus. Litmus is the chaos engineering infrastructure. This is a set of tools that can run on any Kubernetes cluster. It's at another Kubernetes application itself. And who can use this is anybody that's writing a Kubernetes application to harden that application, or anybody who's deploying an application and building a pipelines, or SREs like managing the applications in production. And why it is needed is really to quickly build your pipelines to test, harden your applications. In Kubernetes, we all know it's under very much active release management. So you often have a need to build pipelines in pipelines where you have to continue to upgrade your pipeline infrastructure itself because you got a new version of Kubernetes. And how do you validate that your pipelines are going to be working in the new Kubernetes version? So you need to validate that as well. So there is a lot of churn in validating your continuous changing microservices applications. So you need this Litmus books, which are nothing but predefined set of YAML files that run as Kubernetes jobs. And with putting them together, you will be able to build these pipelines for any version of Kubernetes or any version of stateful applications quickly. If you know them, how to put them well, use them well, it's easier to create an end-to-end pipeline within 30 minutes. And it's going to be really helpful in hardening your production system because even after you roll out your application, the fault tolerance and resiliency, as Adrian mentioned in the very beginning, is pretty needed and important and key. And by using chaos engineering experiments through Litmus, you continue to test what happens if a component or a system breaks, whether my system continues to run or not. And that's how it gets run. And what I want to actually show is, an example implementation of how we have been using Litmus to build a pipeline. So this is an example of our daily commit pipelines. For every commit, there are detailed pipelines that get run. And then each pipeline will have a lot of stages, as you all know. And what's more important is each pipeline will have a set of jobs, which are nothing but Litmus books. So I have, for example, here 31 jobs, right from deploying Kubernetes itself to deploying certain applications, and then really running some functional tests, and then chaos things. All these are nothing but predefined Litmus jobs. As an end user of Litmus, I will never have to go learn deep information about how to set up a pipeline. If I know how to use Litmus, I would be able to set up our deep pipelines using Litmus. And the second one that I want to show is Maya Online, maybe another 2 minutes. Maya Online is a cross-cloud visibility platform where you can connect any of your Kubernetes clusters to Maya Online. It can also be deployed on-prem if needed. It's coming pretty soon, the on-premise version of Maya Online. And here, for example, I have a Rancher cluster that's connected. So let me go there, and I have an application that's running inside the Rancher server inside the Kubernetes server that's running on Rancher platform. And as you can see that this is a visibility platform at the moment, and I could go and see what are the applications that are running, what's my data layer, how is my OpenEBS cluster, and different status of the data plane, control plane, you can keep seeing it. And then most importantly, we have a topology, monitoring, and logs and alerts. So these four together form a good stack for visibility of how your Kubernetes is working with respect to the stateful applications that are using OpenEBS. So let me just go to one of the applications here. It's a stateful set, and I have got three replicas of the stateful set for Redis here. And I could go, and this is a monitoring and topology and logs. So I could go and see the topology. This is yet another interesting view of your Kubernetes resources. Right now we are looking at the volume view of this Redis stateful set. As you can see, here we have about 3 replicas of Redis server, server 1, 2, and 0. And each one is really attached to a PVC, and PVC attached to a PV. And because Kubernetes OpenEBS is a container attached storage, it really provides a full set of storage controller for each volume. So this is the storage controller, and it itself has 3 replicas at OpenEBS layer. And you can go to the pod view as well of that. That's the custom resource view, and here is the pod view of the same application. And using this topology view, you could really go deep into the pod level and see the resources online from anywhere. It helps you get access to your Kubernetes servers anywhere. You could describe the resources, you could get the logs, you could see the entire CPU and the process level and how the data is flowing from which container to which container. Everything is on tips. So this topology view really is helpful as you expand your cluster. You'll have thousands of microservices, and you just want to pinpoint immediately to a given resource and see how it's going. The monitoring piece of it is really a Prometheus stack that puts together in a hosted manner to upload all the data into Maya Online. It's a hosted platform. And here, over a period of time, you could actually see how your replicas, let's say that a replica goes down and how it went down and how it came back, you could see. And the other set is really the logs. So this logs is a set of services built on EFK, the well-known Kibana give you a full control of how to manage your logs. So these logs are available for all your applications. The moment you connect your cluster to Maya Online, all these logs are get collected automatically and then uploaded to Maya Online. So with these 3 services together, you get a nice visibility platform. And soon we are going to launch DMAS, where you could take your application from one cluster and move seamlessly to any other Kubernetes cluster, and the moment will be almost instantaneous. So together with DMAS and visibility, you get and assurance, you will have the data agility platform that provides a cross-cloud data layer for easy management of your both day 0, day 1, and day 2 operations. So that's a quick introduction and a preview into Maya Online. And we do have a good solution document that we recently released for OpenEBS and Rancher. If you just Google OpenEBS Rancher Solution Guide, you get the first link. So here, the solution guide should provide you more details onto what are the real benefits of using OpenEBS in your Rancher stack, and how these two are really complementary solutions that can be put together and get the benefits of building an enterprise-grade storage layer at a very economical value proposition. So back to you, Adrian. That's what I have. I'll be happy with answering any questions that comes my way.
Awesome. Thank you. Yeah, let me take this screen back and wrap up before we go to Q&A. I have a couple more slides. So OpenEBS and Rancher are solutions designed to solve specific pieces of the entire equation. Complexity does not lend itself to confidence. A larger, more complicated infrastructure doesn't mean that you are protected when failure happens. If you believe that complexity holds back failure, it doesn't. You still won't be sure. Simplicity is what gives you confidence. Use a cloud provider's services to the extent that they provide real value and no further. Keep as much control over your ability to move as you possibly can. These fish have no idea why they do what they do. One fish moves because the fish next to it moved. Always know why you've made a decision. Support it with arguments that are right for your situation. Don't just do something because you saw it online and it looked like a great answer. And finally, learn something new every day. Develop the skill to architect solutions based on real-world principles of demand and resource availability, both in and out of the cloud, in and out of Kubernetes, in and out of any provider. This will make you a valuable asset to the community, to any place that you work, to yourself, both now and in the future. Matthew, do we have questions?
We do, and thank you guys so much for a great presentation and demo, OpenEBS. Okay, so here, I think the first few are actually for the OpenEBS guys. This first one is from Jeremy. He says, is it possible to use OpenEBS features like provisioning and snapshot, but without replication? I have only one big RAID disk, but many Kubernetes workers. Yeah, go ahead.
Yes, OpenEBS as a concept has multiple storage engines and also and all customizable. So you don't have to use replication with OpenEBS, and in fact, we see that use case a lot too, and especially with workloads that has its own replication or people running on SaaS backend, which has also RAID levels. So you can run OpenEBS without additional replications as well. So you can set it to 1, and you will get only one replica provisioned, but at the same time, so this will kind of unify your storage management experience. If other workloads or if other environment requires replica, you can still do that.
Awesome. Okay, great. All right, here's the next one. Not sure if this is for Adrian or OpenEBS, so we see who might be the better to answer. This is from Marcus, who asks, is there an app or container that benchmarks the storage, like Bonnie++ for Kubernetes?
Uma can answer this better, probably.
Right. I can probably take that. I don't have a full answer to Marcus. So Litmus is a validation platform. Litmus also provides a FIO benchmarking tool. So what you could do is while you're running your application, you could launch a Litmus job with the FIO parameters that are built into it. It should be able to give a profile of FIO, read write, sequential versus random, the standard parameters, and then give you what is the benchmark of the current system. Of course, it does not provide any comparison of whether that's good or not, but that should get you started.
Cool. Okay, awesome. Okay, here, the next one is from Pascal, who asked, I think this is also for Uma, and Murat. He says, this attached storage can replace the NFS. Is there a backup snapshot option to bring these data out on tape?
Yes, a few options available. So one is also built into, and it will soon be on the UI of My Online as well. So there is a technology, what we call DMAS. So you can take complete backup of your application with the persistent data to a remote location, can be S3 or any storage backend. But on the simpler side, if you don't want to take that route, so you can always use the simple snapshots and clones through OpenEBS. Anything you want to add into that, Uma?
Yeah, sure. As I said, OpenEBS provides a good solution for backup and recovery through the incremental snapshots and even intermediate layers. You can push them up to S3 and all. But backing up to tape, we don't have a built-in solution at the moment. Maybe in future, it's a good requirement, especially for a very large sets of data. Not sure how many people are still going to be requiring in this modern age for tapes, but definitely for large sets of data, it may be useful. So we should be able to put some, there should be Linux-based solutions available to move files from Linux systems to tape, and those solutions should continue to work for this requirement. But not really a built-in seamless solution is not available in OpenEBS for the tape at the moment.
Okay, cool. Thank you. Awesome. And this next question is kind of related. This is from Igor, who says, so what is the backup? How does the backup work for this strategy?
Backup really works in two ways. One is for the applications that are providing app consistency features. For example, you could coalesce your application, and at that time you could take a snapshot of the data and the storage layer, and that snapshot can be moved to either a target location directly or to an intermediate location like S3, right? That's one way. This is easy and more powerful as well, because storage is being intelligent in terms of managing the incremental data to a minimal level. And the other one is where the application, for example, PostgreSQL does not support any coalescing APIs, but they do provide a way to take a hard copy of the data by themselves. So in both these cases, Maya Online, using Maya Online, you take, you go and schedule, this is how I want to back up, how often you want to do it, you create a schedule. And if it is providing app consistent APIs, we do take a backup in a smart way. If not, we use the application APIs to take a snapshot at application level and transfer those snapshot to the configured destination location. There will be a workflow, but it will be, if you know the SRM piece of VMware in the previous world, this would be the next generation workflow similar to that.
Okay, awesome, cool. Okay, here's the next one. This is from Arvind, who says, if I use more than one node, where does it create the replica node? Hope not 3 replicas on each node, for example.
Yes, of course. It's a very good question. It will not, there will be anti-affinity policies that will be automatically set by OpenEBS. So if you have nodes across zones, and each replica of your stateful set will automatically go into different nodes. And sometimes it's possible for each replica of your stateful set, you want to have multiple replicas of OpenEBS volumes. At that time also they get spread out across the nodes. So at no situation you will find 2 replicas lying on one node. So that's taken care by the scheduling logic that's built into OpenEBS control plane.
Sweet. Okay, cool. All right, here's the next one. This is from Jesse, who asks, what's the difference between Jive and CStore drivers?
Right. It's called Jiva and CStore. Jiva is really, incidentally, it's built on using Longhorn, which is from Rancher itself. So in the early days of OpenEBS, what we did is we took Longhorn is really a thin and efficient storage engine that can be used to replicate the data and set up an easy solution. It may not provide efficient storage efficient features like copy on write and point in time snapshots, and then storage pooling of the data, thin provisioning. All these enterprise grade features are added in CStore. This was released a year ago, and Jiva is really a good solution for running the storage in pipelines, for example, where the lifetime of your application and persistent volume itself would be few hours at the max, or the data is not going to be very heavy, not large. For example, in edge cases, Jiva can be used. If you're really looking for enterprise grade level pooling of multiple applications, storage into a common pool, just like an EBS cloud volume layers, CStore may be a better option.
Awesome. Okay, great. That was the last question. I will mention that we have one comment. Jeremy says, "Thanks so much. I have a Rancher OpenEBS POC to do now." So great job. Yeah, and I think we can wrap up there. Is there anything else? Any other messages you want to leave us with?
Yeah, community again, community. So yeah, as a rancher, community on Slack is very active. So we are both on Rancher and OpenEBS Slack channels. So feel free to ask us questions and join both channels.
Excellent, so true. And if just in case you all forgot, the link is slack.rancher.io. Adrian, anything else you wanna leave us with before we exit?
No. Do you have follow-up slides?
Yeah, I will take the presentation back.
Get away.
Yes. Let me change presenter. Okay. Can you see the slide, Rancher Quick Start?
Yes, sir.
Okay, great. So in case you all are new to Rancher, you can easily get to the Quick Start guide, spin up a Rancher instance in just a couple steps. Just go to rancher.com, click the deploy button in the top right corner, and it'll bring you to the Quick Start guide, and you can get a Rancher up and running in just a couple minutes, totally free to use for now and forever. We have a ton of cool projects available. You can find them on Git, Rancher, RancherOS, RKE, K3S, lots of good stuff. So you can find that all there. Finally, thank you all so much for being here. As I mentioned at the beginning of the class, we do these nearly every week. So if you go to rancher.com/Kubernetes-master-class, you'll be able to see all of the upcoming classes and the past ones. The past recordings and slides are totally available for you to download for free. Next week's class is on load balancing, and one of our principal software engineers, Murali, will be doing that. Should be really, really good. So be sure to attend that. And this training is recorded. Many people have asked. We will email you all the video and the slides following the training. If for whatever reason you don't receive it in your email, then you can always go back to the registration page where you registered, and the training will be there for you to download as well. And we are on Twitter, #RancherK8s for these classes to keep the discussion going. To let us know how it was, and we will start to hear your feedback. Okay, that's it. Thanks, everybody. Have a fantastic week. Thank you, OpenEBS. Thank you, Uma and Murat and Adrian. Fantastic job.
Thank you, everyone. Glad to be here.
Thanks, everyone. Bye-bye.
Okay. Bye, you all.